Now the another type of a signal which is the most important signal is unit impulse function. It is also known as Dirac delta function. So basically, the unit impulse or the Dirac delta function is defined as del of t. This will be 1 for t equal to 0, and this will be equal to 0 for t not equal to 0. The pictorial representation will be defined like this. So this will be defined at t is equal to 0. This is delta of t. This is the time axis. So the another one of the important property of uh, impulse function is the area under the impulse function. Area under the impulse function is 1, which is defined as minus infinity to infinity delta of t dt is equal to 1, which is this is the most important operation of impulse function, which is the area of an impulse function is always 1. Now let's apply all the operations which you have applied in the unit step signal. Now let's suppose I have to form a signal which is delta of t minus 4. I'll calculate its value at t is equal to 0. So I'll get t is equal to 4. So previously delta of t was defined at t is equal to 0. Now this will be defined at t is equal to 4. At t is equal to 4, I'll get an operation. I'll get a signal which is delta of t minus 4, which is a very simple operation. Now if I need to perform minus of 2 delta minus of 2 delta of t plus 3. So again I'll go in the right, again I will be going from right to left, and there I'll get the signal like this. So at t is equal to minus 3, I'll get an impulse, and its amplitude will be now minus 2. This is the signal and this is the time axis. I will be going in this direction. Okay, we're going in this direction. Now, now the properties. Now the properties of this impulse function will be delta of alpha t, which is defined as 1 upon mod of alpha delta of t. So basically this is nothing but this is the amplitude. So we have been defined delta t was 1 at t is equal to 0. So this will be defined at like this. Okay. So if I need to perform delta of alpha t, it will be same. But now the amplitude will be changed from 1 to 1 upon mod of alpha, which is one of the simplest operation of impulse function. Okay. So now if I have to uh, show like this, delta of alpha of t plus minus beta. So what it will be like this? It will be 1 upon mod of alpha delta of t plus minus beta. Delta of plus minus beta. This is the important operation. This is the important operation. Okay. So now the another property of impulse function is the product property. Is the product property. product property. Okay, so for product property, it will be defined. Let's take a signal like x of t. Let's take a signal x of t. Okay, this is x of t. ठीक है ना? This is x of 0. ठीक है ना? Now let's take another impulse function which is 0. Okay, this is delta of t. So if I multiply this, what I'll get a signal as at x of 0. I'll get a signal. So basically what I have been getting, x of t multiplied with delta of t. So I was getting x of 0 multiplied with delta of t. Okay. Similarly, 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 if I'll be getting delta of x of t, delta of t minus t naught. So I'll be getting x of t naught into delta of t minus t naught. This is one of the important property of this function. So let's suppose I have been taking an example. We have t square delta of t minus 2. So this is defined at t is equal to 2. So this is defined as t is equal to 2. So the operation t square into delta of t minus 2 will be 2 square 2 square into delta of t minus 2. So which will I'll be getting as 4 into delta of t minus 2. So basically what I have to do, I was doing t square at t is equal to 2. I have calculated which was 4. So multiplied I'll be getting delta of t minus 2, which is my answer. Now the last property, which is the most important property of impulse function, is the shifting property. Is the shifting property. Shifting property is defined as minus infinity to infinity x of t into delta of t dt. So if I'll be solving this, what I'll be getting from the scaling property minus infinity, this 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 I'll get as x of zeros into delta of 2 into del t. This is constant. Is constant. So what I'll take constant out. So this I'll get as minus infinity to infinity delta of t dt. And I have told in the initial slide that area under the impulse function is 0. So this I'll get as x of 0. Okay. This I'll get as x of 0. So now let's take an example to understand this. Now let's take an example. Let's suppose I have a signal I, which was minus 6 defined to minus 60 square plus 4 delta of t minus 3 dt. So if I calculate this value, this will be t equal to 3. So I have to check that this t equal to 3 is lying between minus 6 to 8. Okay, so I'll directly calculate this as t square plus 4 at t is equal to c. So this will give me 9 plus 4, which is 13. So here I will be equal to 13. That in that calculation I will be equal to 13. Now let's take another example, which is the last example of this session. Now let's take I is equal to 2 into delta of t dt. So if I'll calculate here, t will be equal to 0. So at 0 0 do not lie between 2 to 4. So I will be directly equal to 0. So basically, this limits the main motive of this that that t t value should lie between the intervals of limit. Okay, thank you for this session.